So in this tutorial, we're going to be building an accountability app or a goal setting app. And essentially how this application is going to work is we'll create a smart contract. A user can then deposit some funds into the smart contract and set tasks to achieve a goal or set accountability tasks. And the only way they can receive those funds back that they have deposited into the contract is by completing all of the tasks that they created. A fun way to set accountability, set some goals, and we're going to be creating a very simple Web3 application here to do that. So here's the application. I'm going to connect a wallet here. I'm going to just connect my MetaMask wallet. Here, you can see I'm prompted to deposit some funds. So I don't have a goal set yet. So the first thing I need to do is set the amount of funds that I want to deposit and hold in order for me to store that in the contract and then get back once I complete the goal. So I'm just going to put 0.03 here. We'll hit deposit funds. We'll get a transaction here to deposit the funds, the 0.03 here that I chose. So deposit that. There you go. Deposit has been confirmed. Now that we have a deposit, I don't have any task created, so I have to create my first task here. So I'll say first task, and we'll just add that. We'll confirm this here. This is going to add our task. And now that I have a task and my funds deposited, you can see here my locked funds is the 0.03 here. Here is my task. We have the ability to add more tasks here. So I'll just say a second task. Add that task. We'll get a confirmation here for a transaction. We can add that task here. There you go, task added. There you go, we have our first task, we have our second task, and we can add as much task as we want. And as we start to complete these tasks, so let's say here, we completed the first task, I'll hit complete task. There you go, task was completed. You can see here, now it is done. Now I don't get back my funds, right, until I complete all the tasks that are on my list. So here, let's complete this second task. You can see here, I have 1.397 ETH in my wallet. We should get back our 0.03 once all tasks are complete. So we'll complete the last task here, confirm. There you go, task is complete. And I should get my funds withdrawn. And you can see here, I'm back to 1.427. And that is going to be the basic accountability or goal setting app that we're going to be building in this tutorial. A way for us to build our own custom smart contracts, learn a little bit about that, and how we can then build Web3 applications around those smart contracts. Hey everyone, Sean Watasa here, back with another video. And in today's tutorial video, we're going to be building our very own accountability or goal setting Web3 application. Essentially, this application will allow a user to store funds and lock those funds within the smart contract and set tasks or accountability tasks that need to be achieved prior to being able to withdraw the funds again. And this is just a fun and creative Web3 application we're going to be building in this tutorial. So an overview of what we're going to be covering, we're first going to create and deploy our very own smart contract that will take care of the on-chain aspects of our application. So this is being able to store the funds inside of the smart contract, creating tasks and making sure that all the tasks are completed prior to being able to withdraw the funds out of the smart contract. We'll then jump in and build out a front-end application for the smart contract where we'll be able to interact with the smart contract like the demo that you saw in the beginning of the video. With all that being said, let's jump on the computer here and let's create our smart contract first. On my computer here, I have my terminal open and I'm going to create a smart contract for our accountability app first. So I'm going to run npx thirdweb create contract. This is going to allow us to create a contract and deploy a contract using thirdweb here. Then we're going to name our project. So we'll just call this accountability contract. And you can select the framework you want to use. So we support Hardhat or Forge. I'm just going to select Hardhat here. And then we're going to give our name to our new smart contract. So I'm just going to call this accountability contract. And for this, we're going to start from an empty smart contract. We're not going to be using any ERC 721.20 or 1155 standards here. So we're going to select empty contract. We'll create this. And once that's done, we'll change into our accountability contract here, and we'll open this up in our code editor. And once in your code editor here, if you did use Hardhat, you'll see a contracts folder. If you used Forge, you'll see a source folder. And within that folder, you should see your Solidity file here. So I have my Solidity file right over here. And you can see that we have a empty contract, and this is what we're going to use to build out our accountability contract. Now I'm going to rename this accountability contract. And here, the first thing I'm going to do is, again, the accountability contract, we're going to allow a user to deposit some funds to lock within the contract. The user then needs to be able to create some task in order to complete and achieve the goal that they're setting to withdraw the funds. And then the user will also need to be able to create tasks and complete tasks that they need to be able to do in order to get the locked funds within the contract. So the first thing we're going to do is we're going to create a struct for our task. So we have a struct here. We're going to say task. And this struct here is going to have our description. So we're going to say string, and we're going to have description. This is going to be the description of the task. And then we'll have a Boolean here of is completed. So we want to know, is the task completed or not? So every task that we create, we have the description of the task, and it should start off as false for is completed. And as we complete the task, we'll switch that to true. What we'll also have to have is an array of tasks, which is going to be our task. And we'll also set the owner of this contract here. So the contract that we're going to be building in this tutorial is only going to be a single contract that works with the wallet that deploys it. Now you could create this as a factory if you wanted to, and the owner of the contract becomes the person who deploys the accountability contract through your factory. But for this tutorial, we're keeping it simple. We're just going to deploy this contract with our wallet, and only that wallet will be able to interact with this contract. And once we have our variables set here, we're going to create our modifier here. So we're going to say modifier, and this modifier is going to be for an only owner. So again, we're only going to allow the deployer of this contract. So whoever deploys the contract, we're going to set them as the owner, and only they should be able to interact with this contract here. So we'll add a modifier saying only owner, which requires that the message sender, so anyone interacting with the contract, is equal to the owner wallet address that we set here. And we'll set that wallet address in our constructor. So we'll say owner equals the deployer of the contract here. And once we have that set, we can start creating the functions for our smart contract. Now, the first function we're going to create is the create task function. And this function is going to create a task and add it to our array of tasks. So we're going to have a function here. We're going to call this create task. This is going to take a string, and we'll say memory, and it's going to take the description. And it is going to be a public function, but only owner is going to be the modifier that we put onto this. So only the owner can create a task here. And then we're going to get our task array, and we are going to push a task, which is our struct here, with the description that we provided here. And then we're going to set is completed to false. And that is going to be our create task function here. Again, we just provide it with the description of our task, and then we add it to our array by giving it the description and setting the is complete to false here. Next function we need to create is the ability for our user to deposit the initial funds that are going to be locked in the contract. So we'll say deposit funds here, and this is going to be a public payable function. And again, this should be only owner should be able to call this function here. And what we're going to do is just allow our deployer wallet of this contract to be able to deposit funds in here. So we are going to require one thing, and we are going to require that the value that we send is greater than 0, because you need to be depositing something within the contract. And that's all we're going to check here. Is we're just going to make sure that the value that is sent in this payable function is greater than 0. So you can put 0.000001. It just has to be greater than 0 in order to actually execute this function here. Now we are going to create a function to withdraw the funds. And this is just a safety function. And in case you accidentally put funds in and you didn't mean to, or you put the wrong amount, we're just going to create a safety withdraw function here that will withdraw the balance in the contract. So we're going to say withdraw deposit, and then we'll say safely. This is going to be a public and only owner function. And what this is going to do is we'll get a uint 256, which we'll call amount. And this is going to equal to the balance of the contract here. So we're going to store the balance of however much of the tokens that we have in our contract. We're going to store that under the amount variable here. We're going to require that that amount is greater than 0. If not, there isn't any balance for us to withdraw. And then we're going to get a payable owner, and we're going to transfer the amount to the owner. So again, this is just a function that we can call directly on our smart contract, just in case for safety measures. In case the smart contract is wrong, maybe something's wrong with the task and we won't be able to withdraw the balance. This is just a function here for us to be able to safely remove and withdraw those tokens. So the next thing we need to create is the functions to make sure that one, our tasks are completed, and for us to check off that tasks have been completed. So the next function we're going to create here is going to be our all task completed. And what all task completed is going to do is just check to see if all our tasks have been completed. If they are completed, it's going to return true. That way we know that all the tasks have been completed and we can now return the balance back to the user. And if it's not, that means there are some tasks that still have not been completed and we can't give that balance back. So this function here is going to be a private function. We're only going to use it within this contract itself. It is going to be a view function, and it returns a bool here. So it's only going to return us true or false if all the tasks are completed or not. And we're just going to create a loop here that is going to take a, so we're just going to say uint 256 I equals 0. And then we're going to say if, we're going to say I is less than task.length, and we're going to iterate through all of our tasks, and we're going to check if task is not completed, then we are going to return false. But if we go through all of them, then we'll return true. And that means that all the tasks have been completed. So again, this is just a function that's going to loop through our tasks to see if they are completed or not, and let us know if all tasks are completed or if there is some tasks that still do need to be completed. We're also going to create a function here that is going to clear task. And this is going to be a public only owner, or sorry, not public, this is going to be a private function here. This is only going to be called within our smart contract, and this is just going to clear out our task array. So once we complete all the tasks, it'll clear out the array. That way, if we want to start a new goal or accountability, we can just create one and it won't have our previous task in that array there. And then the next function we're going to create is the function here to complete a task. So we're going to say complete task. And what we'll need is a uint 256 of the task ID. This is going to be a public function. We'll call this with the modifier of only owner. And in this function, we are going to require a couple things. So first thing we're going to do is require that the task ID is less than task.length. If it is greater than task.length, it means the task doesn't exist. So the task ID that we provide needs to be within the length of the task array here. The next thing we're going to require is that the task that we're trying to complete hasn't already been completed. So we're going to make sure that pass our task ID to find the task, and if it is completed, then we know that it can't be completed. So we're going to just say task is already completed. So we're going to make sure that it is not completed, and that way we can mark it as complete. So with that, we're going to take the task ID, find that task within our array of tasks, change the is completed to true. Now we're also going to check if all tasks have been completed. After we check off that task, then it is safe to withdraw the funds that have been locked in the contract. So we're going to say a uint 256 here. Again, we're going to set this as the amount, which is going to be the balance in this contract. And we'll then set the payable to the owner and transfer that amount out. And we'll then lastly clear the task here. So every time we complete a task, we are going to mark the task as complete. We'll check if that was the last task that needed to be completed. And if it was, we can now give back the balance that was locked to the user and clear out that task array. If all the tasks are not completed, that means there are still some tasks, and we're just going to mark that task that we completed here as complete, but we won't give back the funds that are locked into the contract. And then finally, we're going to create some functions just to get some data back from our contract. So we'll create a function here that says get task count, and this is just going to return us the length of our task array, so we know how much tasks are within the task array. The next one here, we'll just say a function get deposit. So what this is going to do is get our, or we'll just call it get deposit. Function get deposit is going to return the balance that is stored in the smart contract, so we know what the amount of locked funds is within the smart contract. And then the final one here, we are going to say get tasks, and this is just going to return us our task array so that we can get the task and display it in our Web3 application. So that does it for our accountability smart contract. Again, we have the ability to create tasks, deposit the funds to lock within the contract, a safety withdrawal function here, and the ability to check if all tasks have been completed, and then the function to complete a task and determine whether or not the contract should pay back the locked funds, or if there are still some tasks that need to be completed before doing so. Now with our contract being done, let's open up our terminal here in our code editor, and I'm going to deploy this contract with thirdweb. So I'm going to run npx thirdweb and deploy here. And this is going to compile our contract that we just built. It's going to open up a tab in our web browser where we can deploy this contract using thirdweb's dashboard. So there you go. We can see here we have our accountability contract. We don't have any parameters or anything that we need to fill out for our contract. The only thing that we had within our constructor is it's going to set the owner to the wallet address that I am deploying this contract with. And again, in this tutorial, this is a very simple application, and only the wallet address that deploys will be able to interact with the smart contract. But of course, you can do some tweaking to the smart contract and this application to make it usable for everyone. But in here, I'm going to select the network or chain in this dropdown that I want to deploy to. We support any EVM compatible blockchain, testnet, mainnets. Just search your chain name or chain ID, and you can deploy to that EVM chain. This tutorial, I'm going to be using base Sepolia, their testnet here, so I'm going to select that, and I'm going to click on deploy now. So here I have a transaction that pops up to deploy my contract. I'm going to hit confirm. Then we get a signature request here to add it to our thirdweb dashboard, so I'm just going to sign that request. And once that's deployed, you can see here I'm on my contract dashboard. I have my accountability contract. And if I come to the Explorer here on the left-hand navigation, I have my write functions and my read functions here. So these are all my functions here, from complete to creating tasks, depositing funds, and our safety withdrawal here. And then we have the read functions to get the deposit, task count, task, and everything within our smart contract. So now that we have our smart contract deployed, we can now build the front end for this and start interacting with this contract. So I'm going to come back to my terminal here, and I am going to just clear this, and we're going to build ourselves a new Next project here. So I'm going to say npx create next app, and we're going to call this our accountability Web3 app. We'll say yes to updating it. So we're going to say yes to TypeScript, no to ESLint. We're going to say no to Tailwind CSS. We are going to use source directory and app router here. And I'm going to say no to customizing the default. So once we've created that, let's change into our accountability Web3 app here. And let me just clear this out. So we're in our project folder here, and I'm going to install thirdweb. So to install thirdweb, you can use npm yarn pnpm bun You can check it out in our docs on how to install thirdweb. I'm going to be using Yarn here, so I'm going to put yarn add and thirdweb to install thirdweb into my project. And once that's done, we will open this up in our code editor here. So now in our next project, we need to set up thirdweb to work here. So in the source folder and then in the app folder, I'm going to create a new file, and I'm going to call this file here client.ts. And this is where we're going to create and set up our thirdweb client here. And what we'll need here is, let me just close this on the side. We're going to create a variable here called our client ID. This client ID for this here, we're going to store it in a .env file. So I'll say process.env.next public client ID. And what we'll do here is then export a variable called client. And this is going to be our client here. And we're going to use the create thirdweb client. And we'll make sure to import that here. So we're just going to import create thirdweb client from thirdweb. And what we need to do here is provide this with a client ID, which is going to be our client ID variable here. We'll also just need to make sure that this is as a string. There we go. And now that we have created our client ID, let's provide it with our action. Now that we've created a client here, let's provide it with our client ID. So coming to my files here, I'm going to create a new file called .env, and in my git ignore as well, just for here, I'm going to add it .env to my git ignore here so it doesn't, and we will then get our next public client ID here. And this is going to be our thirdweb API key. So coming back to thirdweb, if you come to the settings tab here, you can get and create your API key here. I already have one created. If you don't have one created, you can just come over here to create API key, and we'll drop a link down in the description below on a tutorial video walking you through the whole thing. But for this, I'm just going to copy my client ID here, come back to my code editor and paste that in. So with that, we now have a client created for thirdweb, and we can now use that within our application. Next thing I'm going to do is create another file in the app folder. We're going to call this one chain.ts, and we're going to define the chain that we're going to be using within our Web3 app here. So I'm going to be exporting our constant here for chain, and we're going to use the define chain from thirdweb. Now, define chain, you can give it and provide it the chain ID of the chain that you're going to be using, or you can use some popular predefined chains that we have. So if I go to here and I import, I'm using base Sepolia here. So if I go base Sepolia, I can import this from thirdweb/chains here, and then I can use base Sepolia. So again, we have some predefined chains that you can use. If not, you can just provide this here with the chain ID of the chain that you are going to be using. And with that, I have my chain set here, and I'm going to create one more file within this app folder, and this is going to be the thirdweb.ts file. Now in this thirdweb.ts file, I'm going to be exporting the thirdweb provider here, and this is what we will wrap our application with to use the thirdweb SDK. And we're going to import this from thirdweb/react here. Now, the reason we need to create this file here and export the thirdweb provider is we want to be able to tag it with use client here. I am using app router within this next project, so we do need to specify here use client in order to wrap our application with the thirdweb provider. So once we have that exported, if we come back to the layout.tsx file, I'm going to come right down here, and we're going to wrap our application or the children here within our app with the thirdweb provider. So coming down here, I'm going to say thirdweb provider, and we're just going to take the children here and put it in between. And there we go. But coming up here, we want to make sure that that thirdweb provider is imported from our thirdweb.ts file. So we'll go @/app/thirdweb. That way we're importing this thirdweb provider that is tagged with the use client here. And that does it for setting up thirdweb within your application. So now if I open up my terminal here and I run yarn dev, this should run our project here locally, and we should see the boilerplate Next.js template here. There we go. You can see this is what you get when you create a Next project. But we're going to come back to our code editor and we're going to remove all that. So I'm going to come back here, go to page, and I'm going to delete everything in this page here. So let's just grab all this template boiler code stuff, delete it. We'll get rid of these imports here as well right now. And we're going to create ourselves our accountability app. So I'm just going to create a div here, and I'm going to give this div some styling. The styling is just to give it a display flex and to kind of center everything within our screen here. So that's the styling over here. Next, I'm going to add a header here that says accountability app, give it some margin on the bottom. And what we want to do now is add the ability for a user to connect their wallet to our app. And we're going to be using the Connect embed here. So we're going to say Connect embed. And we need to provide the Connect embed with our client here, which we can provide it our client from our client.ts file. And we can also provide it our chain here, which will be our chain from our chain.ts file. Now Connect embed here, we are going to have to also export this from our thirdweb.ts file. So after thirdweb provider here, I'm going to add Connect embed. And coming back to the page.tsx, I'm going to make sure that this is imported from the thirdweb.ts file. So again, all we did was add a title and add the Connect embed. If I come back to my app, and when we come back to our app, so we have our accountability app header here, and we have this Connect modal here, which is our Connect embed, which allows our user to sign in with either a Web3 wallet here, or they can sign in with social logins to use our application. So now we have a way of connecting our wallet to our application. We can start building out the actual front end for our accountability app here. So once someone is connected with their wallet, we'll build out the ability to start using our application. So coming to my file directory here, I'm going to create a new folder. I'm going to call this components. And in that components folder, I'm going to create a new file, and we'll just call this accountability.tsx. And we're going to create our accountability app here. So we're going to say export accountability. And in here, we're going to say, and within our accountability app, we only want to show the actual front end of our application if there is a wallet connected. Because if there's no wallet connected, we shouldn't be able to interact with our smart contract. So what we'll do in order to check if there is a wallet connected is we'll create a variable here called account, and we'll use the use active account hook from thirdweb. And what this is going to do is return us back the connected account, or return us back undefined if there is no account that is actually connected or wallet connected to our application. So with this, we can check here and we'll say if there is an account, then we can return our accountability app here, which will just create some empty div tags. I'm also going to tag this component here with use client. So in our accountability app here, I'm going to just give this div some styling here, just to give it some text align and a minimum width of 500. And once someone is connected, we'll just show them our connect button, which will show them the connected version of the connect button here. So just provide this with our client from our client.ts and our chain from chain.ts. And we'll add this accountability here to our page.ts. So say accountability, and we'll add that in. So coming back to our app now, when I sign in, we'll let this load. So let's say I sign in with a MetaMask wallet. There you go. This is our connect button here. So this is going to allow us to disconnect, and we can then reconnect here. So we know now that it only shows this button when there is a wallet connected to our application. So the next thing we want to do is get the deposit amount and task count amount, because we want to make sure and see if there is locked funds in the contract. And if there are tasks, we shouldn't prompt the user to add more funds or create tasks. We want to make sure that we display them the right step, whether they need to deposit funds or they need to create a task. And we can get this information from our smart contract. If you remember in our contract, if we go back to check it, we created these functions to get task count, to get the deposit balance and everything. So we can read these functions from our smart contract and determine where our user is and where they need to be using our app. So coming back here, we're going to get that data from our smart contract. And we're going to use a hook from thirdweb called the useRead contract. It returns us a data here, which we can just call this one our deposit amount. And again, we're going to use the useRead contract hook. And in order to use the useRead contract hook, we're going to have to set up our contract here. So coming to my files, I'm going to create a new folder here. We'll call this a utils. And in the utils folder, we're going to create a file called contract.ts. And in this contract.ts file, I'm going to store, let me just close this, store my contract address. So I'm going to come back to my contract here, copy my contract address, paste that in right over here. Then I'm going to export my contract, and using the get contract here from thirdweb, I can wrap my contracts to be used within my application. So I can set the client here to the client from client.ts. I can set the chain here from chain.ts. I can set the contract address to the contract address right up here. And the final thing that we'll do is set the ABI. Now the ABI, we're going to create a file for this. So coming back to my utils folder, and I'm going to create a new file. I'm going to call this my contract ABI.ts. And we're going to store our contract ABI here. And to do that, or to get the ABI, we're going to come back to our contract. On the left-hand navigation, we're going to come down to sources. And in there, you'll see your ABI, which we're going to then copy here. And coming back here in the contract ABI, we're going to create a variable here called our contract ABI. And we're going to paste that ABI as a constant here. And when we provide this contract ABI back in our contracts folder here, this is just going to be a way for us to resolve our ABI here and be able to use and call the functions from our contract easy. So we're going to say contract. We need to make sure that we come here and export this here. So we'll say our contract ABI. And there you go. We have now set our contract to be used within our Web3 application. And using the get contract here creates this nice wrapper for us to easily call and execute functions from our contract. Coming back to the accountability app here, in the useRead contract, the first thing we want to get is the deposit amount. So how much of a balance is actually deposited in our smart contract. So the first thing we'll do here is set our contract to the contract, and we'll import that from our contract file that we just made. The next thing we're going to do is set the method that we want to call. So now we'll be able to see all the functions from our smart contract here because we provided it with the ABI. So what we're going to do here is call the get deposit. And this is going to return us the deposit amount of the balance stored in the contract. We'll do the same thing here. So we'll get the data back. And this time we're going to get the task count. So we're going to say useRead contract. The contract is going to be our contract again. And the method is going to be the get task count method. So again, we're getting the deposit amount and the task count here. And the reason we're getting those two back is if there is no deposit amount, we have to prompt the user to deposit an amount. And if there is a deposit amount, but there are no tasks, it means that they haven't created their first task yet. So we have to prompt the user to create their first task. So to do this, we're going to, under our connect button here, we're going to create a div, and we're going to say if the deposit amount, and then we're going to say toString, because we're going to get back a big int here, is equal to 0, and the task count.toString is equal to 0, then we should display the prompt for a user to deposit their initial funds. But if the deposit amount dot toString is, we'll say, not equal to 0, and the task count dot toString is still equal to 0, then we should prompt them to enter in their first task. And if none of them are equal to 0, then we should show them our task list, and they should be able to start marking off tasks within our application. So again, using the deposit amount and task count, we can prompt the user with what they need to see within our app here. So let's first build out this first section here, which is the deposit function, right? If they haven't deposited funds yet, they need to be able to deposit the funds that we're going to lock within the smart contract for them to achieve their goal towards. So I'm going to come back to the components folder here, create a new file. We're going to call this deposit.tsx. And in this deposit.tsx, let's create our component here. And I'm going to give this component some styling right over here. So just again, adding some margin, giving it a display of flexed. And what we're going to do here is we need to create an input for a user to put in the amount that they want to deposit. So I'm going to create a state variable up here for our deposit amount that we will use for our input here. So we're just going to create a header 3 here. We'll say deposit, and we'll give a little description that says, please deposit the funds to hold. And in here, we'll then have an input, which will be a number. And we're going to set this value here to the deposit amount. And we'll set the onChange to set the deposit amount on what's in the input. We'll say placeholder here. We'll put 0.0. And then we'll add some steps here. And then you can increment by 0.01. And then finally here, I'm going to add some styling with some width, padding, border radius, just to make the input section look nice. So if we come back to our accountability here, we can add the deposit component here. Save that and come back to our app here. And we should see our deposit. Please deposit the funds to hold. And we have our input field here. So once a user inputs something, we should have a button here that calls our deposit function from our smart contract and deposits the amount that's within this input field. And to do that, we'll come back to our deposit.tsx file. And under the input here, we're going to use a UI component from thirdweb called the transaction button. And this transaction button here, we'll have it say deposit funds. And this transaction button, we need to provide it with the transaction that it's going to execute. So we'll say transaction here. And what this is going to execute is the deposit funds function from our smart contract. Now we're going to use the prepare contract call here. And with that, we're going to provide it with the contract we are interacting with, which is going to be our contract from our contract.ts file. We are then going to set the method here, and the method is going to be our deposit funds function. And then the deposit funds function is a payable function, and we need to set the value here to the amount that we want to deposit into the smart contract. Now, when doing this, we do need to provide it in way, and we can use the toWay from thirdweb here, and then provide it with our deposit amount to string. So that will convert the amount that we have within our input field to way. That way we provide the right amount to the contract when we call the deposit funds function. And finally here we can say on transaction confirmed, we can just do something like alert that deposit was successful. And that does it for our deposit component. So now when we come back to our app here, we can put in our deposit amount and we can then deposit the funds right over here. So now if we take a look back at our accountability app, once our deposit funds are made, we have to allow a user to create their first task. So we'll create that component next here. We'll go to our components folder. We'll create a new file. We're going to call this our task list.tsx. And we'll create our task list component here. And I'm just going to give this div really quick, a quick styling of margin on top. Now again, for this task list component, we need to be able to add task to our smart contract. So just like how we add our deposit amount, we're going to need an input field for our task that we want to add. So I'm going to just create a state variable here for our task. And then we need to be able to get our task and display our task if there are any. So in this component here, we're going to get our task. And if there are no tasks that exist, then we're going to prompt a user to create their first task. So we first need to get our task from our smart contract. Now we're going to get our data here. We'll name that data task. But we can also check the loading state here. We're going to make sure that is loading. So we'll say is loading task, and we can make sure that we have loaded all our tasks before we prompt anything within our app. And then we can use the use read contract hook here. We'll set the contract here to the contract from our contract.ts file. And then we're going to call the method here. And the method we're going to call is the get task method. And that's going to return us back that array of tasks from our smart contract. So in here, we're going to say, make sure that we are no longer loading is task. We're going to make sure that we're no longer loading our task and that our task dot length is greater than 0. Because if it is greater than 0, then we'll display our task list. But if it's not greater than 0, then we need to let our, again, user enter in their first task. And we'll say, so we'll do this component part first here. Again, this is once they have deposited and they haven't created a task yet, they should be prompted to create their first task here. So we'll create a div here. We'll give this div some styling here just to align everything in a flex and give it a slight margin on the top. And then we'll say h3 here and we'll say create task. And then we'll give it a little description that says, please create the first task to complete. And then in here, we're going to create input. This is going to be text. We're going to set the value here to our task variable that we created up here. And we'll set the on change here to set the task to the value that is in the input. We'll set the placeholder here to something like enter task. And then we'll give this some styling right over here. So let's take a quick look back at our application. So we're not gonna, or actually let's add this, sorry, coming back, let's add a task list to accountability. So we should be able to see our task list here. So we're gonna show our task list here. So coming back to our app, let's deposit some funds. Let's just deposit 0.02 here. We'll hit deposit. We'll get our transaction here. You can see we are having a payable transaction sending 0.02 here. We'll hit confirm. Once we've sent the 0.02, you can see deposit was successful. We should now see our create task, creating the first task here. We can enter our task name, and then we should have a button here to create that first task. So let's create that button. Coming back here into our task list.tsx in the input, right under the input here, we're going to create the transaction button, and we're going to say add a task is going to be the name of the button here. And again, our transaction button, we need to provide it with our transaction that we are going to call from our smart contract. And we can do this with the prepare contract call. And in the prepare contract call, we're going to say contract is going to be our contract from our contract.ts file. The method that we are going to call is going to be the create task function. And we need to provide it with the parameters for that function, which is going to be our task. So whatever we put into our task, it's going to set that as the task description when we call the create task function from our smart contract. And then we can say on transaction confirmed here, we want to set task back to empty, and we can say alert task created successfully. All right, so we can test this back on our application. We now have an add task button. So I can say, hey, first task here. I can add task. We can confirm that transaction. And once that task is created, we should see a blank screen. And that is because when we come back here, if the task length is greater than 0, then we should show the final piece of our application, which is showing our task list along with everything like the locked amount. And we should now give the functionality to the user to start completing tasks. And that's what we're going to build next. But before we start building that out, we want to make sure that we can display our task. We want to make sure that we can display our task and have a button next to it where a user can complete that task. So I'm going to come into my files here. In my components folder, I'm going to create a new file called a taskcard.tsx. And this is going to be for our card that displays the task description and a button for it to be completed or showing that the task actually has been completed. So I'm going to say type, we're going to say task props here. And what we are going to need for each task card is the task ID, which is going to be a number. We need the actual task itself, which is going to be a string. And then we need to know if it is completed, which is going to be a boolean here. We're going to export our task card here, and we are going to then return here, and let's give it a div. Now I'm just going to give this task card some styling, give it a display of flex direction of row, some space in between, aligning, some height, width, background color, padding, margin, and border radius. If you want to copy any of the styles that I'm adding, we'll drop a link down in the description to the repo where you can follow along with the styling. This is just to make sure that it looks nice within this tutorial. But then we'll add some text here, and this text is going to display the task. And we'll then give it some styling here. And then we're going to display either a button or showing a kind of like completed or done if the task is completed. So we're going to check if the task is completed. Then we can display that it something marking that it's complete. If not, we should display a button that is going to allow us to execute the function to complete a task. So if it is completed here, we'll just say we'll show a text here saying done with some styling here, like a background color of green and everything. But if it isn't completed, then we need to show a transaction button. And the transaction button here is going to say complete task. And we are going to then call the complete task function from our contract. So we'll say transaction here is going to call the, well, first we have to prepare the contract call, provided our contract from our contract.ts file. And the method we are going to call here is going to be our complete task function. And the parameters that we need to provide it is going to be the task ID. Now we do need to provide this as a big int here. So we just need to make sure that this says big int task ID. So this is going to call the complete task. We're going to provide it the task ID of whichever task this button is clicked for, and it's going to complete that task, calling that function from our smart contract. And then we can say on a transaction confirmed here, we'll just say task has been completed, and we can give some styling to our button here, right over here, just to fit this within our card. So that does it for our task card. So now when we go back to our task list here, again, what we're going to do up here is we're going to get our task that we got back here. We're going to map through all those tasks. For each task, so for each one, we're going to get a task back along with an index. And for each task that we map through, we're going to display our task card. So we need to provide this task card with our key, which is going to be our index. We need to give it our task ID, which is also going to be our index. We need to give it our task, which is going to be our task.description. And then we need to give it is completed, and that will be our task.isCompleted. So now when I save this and I come back to my app here we should see, oh, we don't see it. Let's come back to our accountability.ts, and yeah, let's add our task list down here in the bottom here as well, because we already added a task. So we should be seeing this last section here. So there you go. You can see we have our first task, and then we have the ability to complete our task here. Now, if I complete the task, it's going to see that all tasks are completed, and it's going to refund me my balance and everything, and we're going to have to restart this process again. But once we're in the app here, this is kind of the final stage. We want to be able to display the total amount that is locked away in the contract. And we want to give the ability for a user to add more tasks if they want to add more tasks to their accountability app. So let's come back to our accountability.tsx here. And in this section here, before we display our task list here, let's create and say, hey, well, let's make sure that we have our deposit amount. And if we have our deposit amount, then we should be able to display, let's add a div here, and we'll give this div a styling here. And in this div, we'll give it a h3 headers, and we'll just say locked funds. And what we're going to do is get our deposit amount, which we got right over here, and display the deposit amount that we have within our contract. Now we're going to have to convert this to Ether here. So we'll use 2 Ether from thirdweb and provide it our deposit amount. Then we can add a little description below saying funds will be returned once all tasks are completed. So coming back to our app here, you can see here, locked funds, we have the 0.02, which we deposited earlier, and it says funds will be returned once all tasks are completed. And then below that, we can add our task list, and we should be able to see our first task over here. Now again, we want to add a add task button here, so when a user clicks there, they can add more tasks to their list of things that need to be completed in order to get these locked funds back. So we'll create that last component here. So coming back here, we'll go into our components, add a new file. We'll call this our add task.tsx. We'll create our component here, giving this div here some styling. Now in this add task, it is going to be a button that opens a modal. So we'll create a state variable here for seeing if the modal is open or not. So we'll just say is modal open. We'll set it to false as the default. And then we'll also create one for task as well, because we're going to be adding in a task in an input field that we want to add. So we're going to have one for task and set task. So the first thing here in this is we're going to create a button, and that button is going to be our add task button. And what this button is going to do is on click, it should set the modal to true. We'll give that button some styling here and positioning. So now if we save that, come back to our accountability, and above our task list, we will have our add task button. Save that, and if you take a look at our app here, you can see here we have our add task, which is going to toggle our modal here. So let's come back to our add task.tsx and let's create that modal. So we'll say here, if the is modal is open, then we should display our div here. And we're going to create a div here. This is for the background of the modal. We'll then create a div for the card of the modal. And then within that add task modal, we'll create a button. This will be the close button to close the modal. And we'll just say on click here, it sets the modal to false. And we can give that button some styling. So again, coming back to our app here, you can see this is our modal. When we add task, we'll be able to input and add our task in here, or we can close out of the modal here. And so this is where we're going to create our input field to add additional task. So below that close, below the close button, we're just going to add some text here that says enter task description, give that some styling. Then we're going to create our input field. This input is going to be of type text. We are going to set the value here to our task, the on change to set the task. The placeholder here will say enter task. And then we have some styling for our input field. So coming back here, there we go, enter task. We can enter the task name, and then we just need a button here to set and add the task, calling our add task function from our create task function from our smart contract. So to do that, we'll do again a transaction button over here that says add task. Transaction here. For this, we are going to again use the prepare contract call. And in there, we provided our contract. We're going to import that contract. We're going to call the create task function and provide it the task from our input. Now on transaction confirmed here, we're going to do a few things. The first thing we're going to do is set the modal to close. So set is modal open to false. We're going to set task back to empty strings, and then we will then just alert that a task has been created. And then finally down here, we're going to add some styling for this button. When we add a task, it should close the modal, reset it. That way, if we want to add more, we can go back in. So right here, you can see we have our modal. So when we hit add task, we can say, hey, second task. We can hit the add task button. It's going to call the create task function from our contract. You can see task was created successfully. It will close that modal, it resets everything, and it adds our second task here. Now we should be able to complete our task. So again, we can hit complete task, confirm that. There you go, task was complete. It should be marked as done now. And then we have our second task and our last task to complete. So once I complete this task, again, in our smart contract, it should see that all tasks have been completed, and it should refund us the 0.02 here. So we should have, currently we have 1.405. So we should get 1.425 as a balance in our wallet once we complete this final task. So we'll complete that. There you go, task has been completed. And there you go, 1.425 is our current balance now within our wallet. And it brings us back to the first initial screen where we can put in a deposit. Once that is deposited, it should prompt us to create our first task, which is right here. So we can just say first task. We can add that first task again. There you go, task was created, and that should bring us to our actual app here where we have our locked amount. We have the ability to add task, complete task. If I were to disconnect and sign out, we don't see our application here. I can connect back to my wallet, and it brings us back to the step that we are currently in, which is showing our full application here. And there you go. We built our very own Web3 accountability app or goal setting app. Again, this is a fun basic application where we went over how to build our very own smart contract and then how to build a front-end Web3 application to interact with that smart contract and do some fun, unique on-chain things with it. But again, I hope you folks enjoyed this video. If you did, give this video a thumbs up, hit that subscribe button, and don't forget to turn on the notification bell so you don't miss out on tutorial videos just like this. If you need any help or support, we'll drop a link down in the description below to our support team where you can open up a support ticket and they can help you answer and help you out with any of your questions. But again, I hope you folks enjoyed this video, and until next time, see ya.